Welcome back to Let's Code. I'm Chris Biscardi, and I want to start talking about macros more, specifically how to use them, and then what kinds are out there, and then how to actually implement them. But today, our starting point is going to be a macro that you will see very often in Rust code. That macro is println. Now, you'll see println extremely often because it's the equivalent of a console log with a new line at the end from other programming languages. So if we use the println macro with the exclamation point, which is how we know it's a macro, and we pass in a string, it'll print hello world out to the console or to standard output. Now, println is not the only variation of this kind of macro, one that prints to the console to either standard out or alternatively standard error. Here we have print, which is println, but without the new line at the end. And of course, we also have the standard error variations of println and print, which will print to standard error instead of standard out. If you're not familiar with standard out and standard error, that's not really today's topic, but suffice it to say, anything that your program should output to show a user is likely to go on standard output. Anything that you pipe to another program on the command line is likely to go on standard output. Anything that goes wrong with your program, any informational diagnostics and things like that, usually gets output on standard error. But we're not actually going to talk specifically about any of those. We're going to talk about format and how to construct the formatting strings that we can use inside of any of these println or ePrintLn macros. The format macro is effectively println, but without actually outputting to standard out or standard error. That means it does all the formatting of the string that we give it and the values that we give it, but it doesn't put that result anywhere. So in this case, format just returns a bunch of strings. I've pulled this code into the Rust playground to show you that that is indeed true. Now, I've replaced format with println because I want the output to actually go to standard out, but the effect is the same. You can see that I haven't changed any of the code. All of the strings and all of the formatting mechanics all operate the same between this variety of macros. Let's spend a few minutes going over what a formatter is and why this works the same across all of these different macros. In the first case here, we can pass println a string, which will output a string, anything we give it. We've already seen this in the last example. We can also use two curly braces to pass any variable in, and println or format or any of the others will template this value in the place of the first set of curly braces. You can see here we've got hello, curly braces, and then an exclamation point in our formatting string, and the value is world. So what we see out is hello world. This is the fundamental basis for how every other formatter operates. There will be a set of curly braces, something inside of it or not, and then a value that we pass in. A very similar thing happens no matter what kind of value we pass in, which is unique a little bit in many pieces of Rust code where a function will only accept, say, a U8 or a string slice or a vec. We can pass in almost anything here. Now, the curly braces here are called the display formatter. The display formatter uses the display trait to figure out how to actually present this value inside of the string. In this case, we have the number 1, which we can think of as like an I32 or something. It doesn't really matter in this case. Suffice it to say, the number 1 is just put in verbatim, and we get the number is 1. If we take a look at the display trait itself, we can see that the display trait requires that we implement a function called format. Format takes a reference to itself, so whatever it's being implemented for, in this case, it would have been implemented for something like I32 or something like that. And the second argument is a formatter. Now, what a formatter is doesn't really matter, but suffice it to say it's a struct that will get automatically handled for us whenever we use one of these formatting strings. There are other traits that do the same thing, or at least a similar thing. In this case, we have the debug formatter, which is the two curly braces on either side with a colon and a question mark in the middle of them. In this case, we've chosen to pass in a tuple where the first value is 3 and the second value is 4. The output here is the debug traits format function for what a tuple should output as. And very similarly to the display trait, the debug formatter is a trait that requires that you implement the FMT function, takes a reference to itself, so whatever we're implementing this for, in this case it's a tuple of size 2, and it takes the same formatter that we were going to pass in, or Rust was going to pass in for us. Now, contrary to display, debug is meant for programmer-facing representations. So when we use the debug formatter, what we expect to see is something like a tuple instead of a, say, human-readable miles and feet or something like that. The next two examples show two ways to kind of interpolate a variable into a specific place inside of a formatter. So for the first example, there is no variable called value in scope, but we can define it where we otherwise would have passed in a value. So we can say that value is supposed to be here using the display formatter, and also that the value is 4. Building on that, if we do have a variable in scope, we don't have to pass it in, because what Rust will do is take the people that is in the current scope and put it into that place in the string. This is a fairly recent addition to the Rust programming language and is garnering more usage quite quickly. It's pretty convenient. Then you can, of course, use multiple formatters in the same string. So, for example, if we have 2 display formatters, then we get to pass through 2 arguments or 2 values. And this is where it starts to become obvious that this needs to be a macro, right? So normally in Rust, if we have one function, we can't pass multiple argument lengths to that same function. We don't really have overloaded arity, as it were. Arity is just a fancy word for how many arguments a function takes. And this is really the first big example for why println is a macro and not just a regular function. You don't really want to be doing like println 2, println 3, println 4 every time you want to write a println for a different number of values. We want to be able to basically read how many formatters there are out of the string at compile time and check that against the number of arguments that are passed in. And macros can let us do things like this. There are also very sort of fancy formatters. Display and debug are kind of the more common ones that you'll see more often. But unlike some other languages, we can pad with a 0 just using the standard library, using a display formatter, and then inside of that, using :04. So that means we're going to pad this numeric value with zeros up to 4 spaces. So what we end up with for the number 42 then is 0042, which gives us 4 digits padded with zeros if it doesn't actually have 4 digits. You may recognize the next example as a debug formatter with a hash or hashtag or octothorpe or whatever you want to call it split inside of it. This is saying that we want the debug formatter, but we want the alternate version of it. So in this case, what that means is we get the debug formatter, but we get it pre-printed instead of just all on one line. So we compare this to the 3, 4 that we had earlier, which are all on one line. And if you pre-print a tuple, each of the values here gets put on its own line, including the parentheses. And you can see that we've got the appropriate number of trailing commas on each value. And again, there are quite a few different alternate forms, right? We can add things like 0b or 0x in front of our numbers, or we can force numeric types to always show their sign with a plus. There are quite a few variations on the kinds of strings that we can pass in, the number of different formatters that we can use. We can control the amount of space we want to take up with a particular output. We can control where something is in relation to other characters and align a character to the left, center, or right of a particular string. And you can find a list of different kinds of traits in the standard format docs. So we can see here display and debug, which we've covered already. But there's also quite a few others. There's binary, there's upper hex and lower hex for things that look like CSS colors. And if you want your struct or your value to be printable in these ways, you can implement these traits for your custom struct. In addition to print, println, eprint, and eprintline like we talked about, and format, of course, there's also write and writeline, which are more generic versions of, say, print and println, which can write to different destinations. And if you really want to dig into it, you can find format args. Format args is like sort of the ancestor of all of the other formatting macros. All of the other macros are built in terms of format args. So again, if we just look at the pure variety of different kinds of strings and behaviors we can get out of all of these formatting macros, we can start to see why a regular Rust function or a single trait is not enough to actually implement the behavior that we want. And this will lead us into, why do we have macros at all? Why can't everything be written in just functions? Hopefully you understand a little bit more of that now. Like, functions can't accept multiple different lengths of arguments, right? You can't call one function that accepts 1, 2, and 3 arguments. That's one of the reasons that functions often take an option type. So in future videos, we'll go deeper into macros. I think one of the next videos will be exploring the macros that are out there. I think there are really some interesting ones. There's some for Saturday, there's some for Tokyo. But one thing that I would like to say is, if you're planning on writing a macro, or you want to get into understanding more about macros, macros are a last-ditch API choice. Basically, when you can't get done what you want to get done using the other affordances that Rust gives you, then start thinking about, okay, can a macro actually do what I want? And why, you may ask? Well, macros themselves are quite complicated. They're complicated to write, and they're also complicated to read. They're also, in addition to that, complicated to manage the error handling for. So you may have used a macro in the past where the author didn't quite handle all of the edge cases, and thus you got an error that was really hard to debug, because it's really hard to handle errors correctly when you're writing macros. So all of that added complexity comes with the additional power that macros give you. If you're familiar with AST transformations in other languages, you can kind of think of macros as a built-in mechanism to do that, especially if you're familiar with something like Babel from the JavaScript ecosystem. Instead of Babel plugins, crates can offer custom macros that read in a set of Rust tokens and output different code than the code that you wrote. So that's it for today. I just wanted to get a start on macros, give you a little bit of a pointer to why do we need macros in the first place. If you have any questions or want any, or have any specific macros that you want me to dive into in the future, leave them in the comments, and I'll catch you in the next video.